A very good morning to Dr. Mazar. My name is Kaushina Analaki BK7, and today I'm going to present about the introduction of dynamic group project. So without further ado, let's go. In this introduction, we're going to discuss about the significant impact of dynamic system on various scales. Dynamic, which deals with motions and force, influence our daily lives and drives innovations in engineering and technology. So the main focus of this project is two cylinder engines, which is based on two piston crankshaft assembly, demonstrate dynamic principles by converting chemical energy from fuel into mechanical energy through controlled explosions. Now we are going to look into the objective of this report. So first of all, a two-cylinder engine converts fuel energy to mechanical energy using piston crankshaft. Each component helps achieve these goals. So next, piston compress air fuels mixtures harvesting combustion energies. This expands gases that push downwards for linear motion. And the third one, in a two-cylinder engines, piston move up and down, transferring power to the crankshaft with connecting rods, and this proves that motions into the rotary motion driving the gearbox that moves the wheels. This engine contributes transform energy from fuel combustion into rotary motion, providing the vehicle's powers. These are the three objectives we found from this report. So that's all.
My name is Kevin Kaunda Suluraju. My metric number is CD230058. Here's the methodology for our project. First, translation considers the rigid body which subjected either rectilinear or curvilinear translation. The formula for the position is RB equals to RA plus RB over A. RA and RB is a position vector, and the RB over A is a relative position vector. Next is velocity. The formula is VB equals to VA. Because of the direction, RB over A is constant, and the acceleration, the formula is AB equals to AA. Because of the curvilinear and the rectilinear translation move along with the same velocity and the accelerations. Next, the rotation about the fixed axis. Angular velocity is the time rate of change in the position is called as angular velocity, which the formula are omega equals to d theta over d time. The next is angular acceleration, which is alpha measure the time rate of change of the angular velocity, which is the formula is d omega over d time, or we can call as alpha equals to d square or theta over d t square. And the next is the constant angular acceleration. There's the total three formula which is shown in the slide. Moving on to the motion of point A, as shown in the figure in the slide, there's a total two formula. First is the velocity, which is V equals to omega times position vector. Next is the acceleration. The formula is acceleration tangential equals to alpha times position vector. And next is acceleration normal equals to omega square times with the position vector. The last one is relative motion analysis of the velocity. As stated in the translation, the position formula is the same as in relative motion analysis, and the velocity of the formula is velocity point B equals to velocity point A plus by velocity point B over A.
Hello everyone, my name is Madanraj Analagisagaran. Today I'm going to talk about the calculation. So the question is, the two-cylinder engine is designed so that the pistons are connected to the crankshaft BE using a master rod ABC and articulated rod AD. Rod AB and CB are connected together. The length of DA equals to 198 mm. AB equals to 92 mm, BC equals to 196 mm, and BE equals to 86 mm. The piston C is slightly tilted by 38 degree. If the crankshaft is rotating at W 30 radius per second, determine the velocities of the piston C and D at the figure shown. Now let's look at the kinetic diagram of member BC. Firstly, we need to find out the velocity of B. The formula will be VB equals to angular velocity of BE times position vector of BE. So we will get 2.32 meter per second. And then we need to find the velocity of C, which is the formula will be velocity c equals to velocity b plus velocity bc. Okay, now let's arrange the equation. The equation will be minus vc cos 38i minus vc sin 38j equals to minus 2.32i plus negative angular velocity of bc times k and dot product 0.196 cos 56i plus 0.196 sin 56j, and then we use the cross product, and then we'll get the value of v b slash c, and the answer will be 0.1625 angular velocity of bc I minus 0.1092 angular velocity of bc j plus 0k, and then we'll form two equations to find out the value of angular velocity bc, and the answer will be 7.656 radian per second. Now the next step will be to find the velocity of c. To find the velocity of c, we need to substitute all the answers we got from previous equations. Now we will get the value of velocity c, and the answer will be 1.363 meter per second. And finally we will find velocity of b slash c, and the answer will be 1.5 meter per second. Now let's look at the connected diagram of member AB. We consider that A is velocity A equals to velocity B plus angular velocity of BC times position vector of AB. The reason why we using angular velocity of BC, because the rotation will be same for the both members, which is BC and AB. Okay, now we'll find out the equation of velocity A, and it will be minus 2.32i plus bracket minus 7.656k times bracket minus 0.092 cos 34i plus 0.092 sin 34j. Now we'll find the cross product and substitute the value into the equation of velocity A, and finally we will get velocity A equals to negative 1.926i plus 0.584j. Now we will find the magnitude of velocity A, and the answer will be 2.013 meter per second. And then finally we will find magnitude of velocity AB, and the answer will be 0.705 meter per second. Now let's look at the connected diagram of member DA. We'll consider D is velocity D equals to velocity A plus angular velocity of AD times position vector of DA. The equation we'll get is negative VD cos 34i plus VD sin 34j equals to negative 1.926i plus 0.584j plus angular velocity of ADK times bracket minus 0.198 cos 34i plus 0.198 sin 34j. Now we'll do the cross product and substitute the value back into the equation, and then finally we'll get two equations, which is 3 and 4. Now we'll make the VD, which is velocity D, domain, and then we'll get the equation 3 plus equation 4, and finally we'll get the angular velocity of AD equals to 8 radian per second. Following this, we'll find out the velocity of D, and then the answer will be 3.39 meter per second. And the final step will be to find the magnitude of velocity dA, and then the answer will be 1.583 meter per second.
Sharma, son of Vishwabharati. My matrix number is CD230312. Today I would like to discuss of my group project. First of all, dynamic principle in two-cylinder engine operation. The piston crankshaft mechanism transforms linear motion into rotational motion driven by time explosion. These principles are crucial for engine functioning and are applicable in mechanical engineering. Piston motion and forces. Experiment determine piston velocities using vector addition and cross product calculation. The piston velocity was found to be 1.363 meter per second with a relative velocity of 1.5 meter per second. Crankshaft rotation. The crankshaft angular velocity is crucial in determining the motion of connected rods and piston. The crankshaft's rotation at 30 radians per second effectively translates repercussing piston motion into rotary motion. Next, the last one, energy transfer and efficiency. The piston crankshaft mechanism facilitates the transformation of chemical energy from fuel into mechanical energy. Future studies could explore the impact of different fuels on engine dynamics and effect of different crankshaft and piston designs. Thank you. That's all from me.
Hi, my name is Tanasinalaki Ravi and my matrix number is CD230093. Today I'm going to present our conclusion. This experiment successfully demonstrates the application of dynamic principle in a two-cylinder engine. The detailed analysis of piston and crankshaft motion coupled with the understanding of forces and energy transformation highlights the intricate mechanics involved in the engine operation. The findings provide a foundation for future research and development in the field of mechanical engineering aimed at optimizing engine performance and efficiency. Thank you.